Be doing is 8.2H standard deviation. So what I want you guys to do is take out your notes just as if I was teaching this class. You guys are going to watch this video, take notes. We're then going to discuss it during office hours, and then what's going to happen is we're going to have an activity based off each lesson. So let's go ahead and start off with this. So we're going to look at some data. We're going to look at some jargon really quickly. So right here it says, after spending time analyzing the data, so if you remember the person with the cell phones, Rachel and her mom talking about sending so many text messages. So after analyzing the data collected about the number of text messages sent each day, Rachel was convinced she needed more information to create a valid argument that she spends an appropriate average number of texts per day. She realizes that she could not compare the amount of daily text messages her friends send against the amount the daily text messages her mom's friends send. It is clear that teenagers send more text messages. Rachel was determined to show the amount of text messages she sends each day is about the same as other teens. To do this, she researched the internet and found a survey of 1,200 teens. The teenagers that an average of 115. So that's basically the mean. Now, I really want you to realize this. In statistics, yours looks a little different right here. In statistics, this means our population mean. So the population she was looking at is 1,200. So that's the mean. That's the symbol that we're going to look at there. Text messages each day, and the standard deviation, and it's this kind of weird looking O symbol right here with a little thing hanging on it. That means standard deviation, and we're going to look at what that means shortly, okay? Rachel didn't understand the term standard deviation, so she looked it up, and here's what she found. All right, so standard deviation, once again, just weird looking O symbol right here, is the set of data measured how spread out the data is. In other words, it tells you whether the data items are bunched close to the mean. So remember, the mean is just that funky looking U. Or if it is all over the place. Standard deviation provides a good rule of thumb of deciding whether something is rare. Whenever a set of data is normally distributed, these statements hold true. Now, key word here is normally distributed. When it's normally distributed, it makes a nice pretty bell curve. And it's basically saying, hey, we're at the center. This is the mean. And so we're going to use this symbol for mean now. So this is the mean. And how far away are we from the mean? Okay, how far are we away from the center of the bell curve? So if I were to draw this, here's my mean. How far away am I from the bell curve? Am I in the higher percentile or am I in the lower percentile? And we can talk about that using what's it called? Standard deviation. So let's go ahead and look at this. We're going to look at this as there's 1, 2, and 3 standard deviations. So when I go ahead and look at this, let me bring this up really quickly. It says approximately 68% of all results are within 1 standard deviation from the mean. Approximately 95% of the data is within 2 standard deviations of the mean, and approximately 99.7% of the results are within 3 standard deviations of the mean. So here is a bell curve of data. One very common is on test scores or like baby's height or baby's weight. Every time we go into the doctor's office, they tell us what percentile we are. And we can look at this as a bell curve, a normal distributed set of data. So for instance, let's just say the average on a test was an 80%. Here would be like a 99. This would be like let's see, like probably like a 72. Basically, how much of the data is here. So if you are in the mean and something is 1 standard deviation greater, above and below the mean, that would cover 68% of your data, okay? So here was the mean, and 1 standard deviation above and 1 standard deviation below the mean would cover 68% of the data. If you were now 2 standard deviations away, that would cover everything in green as well as this candy blue. This would cover 95% of your data. So this covers 2 standard deviations away. covers 95% of the data. Remember, that would be above and below the mean total. Okay, and finally, if you were to include 3 standard deviations away, that would be this part all the way here and all the way here. That would be 99.7% of your data. So that would be 3 standard deviations away. So if you're above these points, you're very, 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 very high, okay? So just another way to go ahead and view this, guys. Remember, this is the mean. So this is like 50% are above and 50% are below a normal deviation. If 68% of the data is between these 2 marks, we can say how much is above it. Well, 34% is above and 34% is below. Okay, so this would be 1 standard deviation above is 34% of the data, and 1 standard deviation below the mean is another 34% of the data, with a total of 68% of the data. Okay, so you continue that. We're going to go ahead and continue to explore this of what this would look like in several different situations. So let's go ahead now and look at this. It says I want to create a histogram set of data. So these are my pieces of data, and I'm just going to take a quick little highlighter, and here we go. So we have 30, which would be right here, and then I got 70, which would be right here. Now, I always say if it's 80 to include it, like this is 80 and above right here. So 80 and 85, that's 2 spots. So 110 to 1 would just be right here. And then I have 130, 137, 138, 140. So that would be 1, 2, 3, 4. So you can see more data is getting put here. Next, what we got here is 140 to 160. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would be this. Okay, next we have 62, 63, 64, 175. So that would be 1, 2, 3, 4 pieces. So it looks pretty straightforward, but then I also have this giant outlier over here of 175. Because of that, I have this kind of like bell curve shape because I have that giant outlier pulling that out, okay? So here we go, guys. Here is my information here. Now, what we're going to do is we are going to use vocabulary from 8.1. So I know that was a while ago, but when we think of words, is this bimodal or unimodal? Does it have 2 bumps or 1 bumps? And I would say it's unimodal. And it says, do I have any outliers? Yeah, I think 275 looks like an outlier to me. And then let's see, what kind of distribution in here? Is it skewed left? Is it skewed right? Is it uniform? And I would say it's pretty much normal distribution. And more so because of this one right here. So this would be normal distribution. And then, does it have low variability or high variability? So is everything kind of clumped together, or is it all over the place? If something were to look like this would be high variability. Since they're all kind of clumped together, I'm going to say it has low variability. Okay, so now let's go ahead and look at this. How do we actually calculate a standard deviation? So how far are we away from the mean? So a few things. This is what your textbook says, your notes. This is the actual formula. I'm going to change it just a tad. Looks a little different the way, these are both going to mean the same exact things, but it's just the way I'm going to write it. So if I looked at this whole thing would be divided by n. Now I want you to be aware, if you ever looked this up, there's a thing called sample size standard deviation and population standard deviation. And the only difference is going to be the denominator. This symbol right here means population. Now, population doesn't mean everyone in the world. It means basically who are you surveying. So if I wanted to look at the population of our Math 1 class, the population would be 43 students. If I would say you guys compared to the rest of the school, you guys would be a sample size of the entire school, but not the population. So just to let you know, guys, this is the standard deviation of the population. So let's go ahead and look at everything here now that we see this symbol. It says, in her old textbook, Rachel found the following steps for calculating standard deviation. It says, first, find the mean. And then it says, find the difference between each data and the mean. So basically, you're going to take your mean and you're going to minus the value. You're going to, one more time, let me flip that. You're going to take the value, so the number of text of individual persons submitted, and you're going to subtract the mean from it. So this might be positive or negative. To make sure all values are going to be positive, we're going to square them. Then what we're going to do is we are going to then find the average mean of these squares. So we're going to add them up all again, and we're going to find the mean of those. And then what we're going to do is we're going to take the square root of those. So here it is, guys. This is the formula we just figured out. So I'm going to rewrite this again. So the standard, and go ahead, feel free to do this too to make it a little better. The standard deviation of a population is the square root. So this is basically taking all of this and taking the actual formula and making it in here. So it's going to be the difference of the summation of the mean. So it's going to be the sum of the x value minus the mean squared. And then you're going to just divide that by the population. Okay, so let's go ahead. Hopefully that makes sense. If not, we're going to do this example together. So the first thing what we're going to do is we have this, it's giant data. So it says, following the above steps, find the standard deviation of Rachel's data. Now guys, in my opinion, these are 24 submissions there. It's way too many to do a first one. But let's go ahead now and actually look at this. X represents the data, and this should be, we got a fancy U right there. So let's go ahead now and look at this. The first thing what we are going to do is we need to find the mean. All right, so this is my X values, and the U is my mean, so I got to figure that out. So what you guys would do is you would take a calculator and you would legitimately add up every single one of these numbers, so 36, 70, so on and so forth. And then I have the second ones on the next page. And what you would do is you would find the mean there. And I already did that for you. Now this page I'm going to do a lot of this part for you. So when I did that, I got 139, and I believe it was 0.16 repeating. But I'm just going to have the mean be 139. So the first thing that we want to do is find the difference of these. So I'm literally going to go ahead and do this 136 minus 139. And I'm going to go ahead and do this really quickly, and you guys can copy along with me. And I'm literally just taking my X values, and I'm going to minus the mean from them, okay? Okay, so now we got all this written down. And now what we need to do, guys, is we are going to find the difference in all these values, okay? So, and then we're actually going to square them. So, guys, when I subtract these, I'm going to write those values here. So when I subtract these, I'm going to have negative 103 to the second power, which is 10,609, and I'm legitimately going to do that for every single one of these values. So go ahead and double check my work. I did these pretty quickly just to make sure I got the right answer. So this next part, guys, in my formula really quickly, if I go back here as I'm doing it, what I'm doing is this part. I found the difference of those values, and then I'm going to square it. So that's what I'm doing right here. I'm finding the difference in those values and squaring it, okay? Almost done. Ay, ay, ay. And then we got 136 to the second power is 18496. Oh my goodness, I know that was probably the boringest part of this video. So guys, what we just did here is we found all of these values. And what we are going to do now is we are going to add every single one of them up, okay? Now, if I did this correctly, and you know how good I am at mental math, so what I'm going to do now is I'm going to add up all of these parts. So one more time, guys, if we looked at my formula, which I will show you right here, what we are going to do is find the square root of the addition of every value. Let's see, we got x equals 1 to the nth term. Okay, so we are going to add up the sum of my x value minus the mean, but I want to make sure they're positive values, so I'm going to square that. Once again, this is what I just did in pink. So I'm going to find the sum of them now. So what I'm going to do now is this part right here. I'm going to find the sum of all of them, and then divide by the total population, which was 24. So if I did that, and I have it written down really quickly, let me bring this up. It would be 45240 all over the total population, which is 24. So one more time, we found the sum of the difference between your x values and your mean. So I found my mean first, which I kind of just wrote out for you. I found the difference of my x value and my mean. I squared it, and then what I did with those squared values is I added them all up to get my numerator. I'm then going to divide it by 24, which would give me then the square root of 1885. So then if I just took the square root of that, which I will do on my calculator right now, we would get a standard deviation of, let me go ahead and do this, 1885 equals 43.4 and a repeating decimal. So 658 ... So I'm just going to round this to about 44. So if we go back to standard deviation now, what that actually means, it's saying if I were to look at my data set now, here was my mean. I had an average text of all of Rachel's friends send 139 text. And I want to figure out what one standard deviation above and below, two standard deviations above and below. So what I would basically do is just take 139, and all I would do is add my standard deviation, which was 43. So I'm going to add 43 to all of these. Oops. And then two standard deviation, which is just 139 plus 2 times 43. So on and so forth. And we would do the same over on the other end. So let's go and look at these values. My mean was 139. And then if I add 43, so 139 plus 43, that would just give me 182. And then two standard deviations away. Hold on. Would be 225. And then three standard deviations away would be 268. Now on the other end, if I started with 139 and I wanted to figure out what one standard deviation to the left would be, so the left, I would just subtract 43 to get 96. And then if I took 96 and subtracted 43 again, that would give me 53, and do it again to get 10. So what is this saying, guys? It says if I were to look at this girl's data, Rachel's data, and I said what number of students would be one standard deviation away, it would be this data right here. Anyone between these two standard deviations, this would represent 68% of the data. This would represent 68% of the data. So if you if you're between 96 and 182 texts a day, you are within one standard deviation above and below the mean, and that covers 68% of the data. Now let's look at two standard deviations away. That means if you, and I'll change the color so we can see it, if you're right here, if you're between this area, so right here and right here, and we're always looking inwards. So I'll go ahead and shade this a different color so we can actually see. So this green part right here, if you're in between these spots, you are between 95% of the data. Now, if you are 3 standard deviations away, which includes everything in the green, you are 99.7% of the data. So right here to right here, that is 3 standard deviations away from the mean. And I'll go ahead and make the mean, we'll make the mean red. So if you're at 1, 2, 3 standard deviations away from the mean, which is everything in green and as well as what I'm going to highlight in purple, that is 99.7% of the data. And if you look at it, we still have that outlier, which was like 275, which would be like right here. This person would be an outlier. They're way, way, way above everything. So yeah, there we go. So Rachel wants to continue using an average of 150 text messages per day. With the results that you were able to obtain in 3 and 4, write an argument with Rachel. So she wants to send 150 text messages. So I'm going to erase this work part right here. And if I have 150 text messages, which is right here, you can say it looks reasonable enough to me. So on number 4, we could say, well, the average is 148. Excuse me, 139, and 150 is just a little bit more than average, but she's still within that 1 deviation above. She's barely above the mean. And we can also say that 68% of the students, 68% of the students are within 1 standard deviation above and below. So she's right on par with 68% of her peers. So 150 text would be 1 standard deviation from the mean, and 68% of her peers are within 1 standard deviation above and below the mean. Okay? All right, so Rachel wants to continue sending, so we just answered number 5. So let's go and jump to number 6 now. So number 6, we're going to have a little bit more smaller numbers, and we're going to kind of understand how this works. And it'll be easier to actually find these because I can actually do all these on one table. So it says 3 people are seated at the table. Now their ages are 8, 10, and 12. All right. So it says find the mean. So this is pretty easy. We got 8 plus 10 plus 12. So we have an average age of 10. So that's the mean. So then it says find the standard deviation. One more time, a standard deviation is the square root of the sum of the numbers of your x value minus your mean squared all over your total population. Okay, so right here what we would do is I'm going to look at my population. I have an 8, 10, and a 12. Okay, so that's my population. Then what I'm going to do is I'm going to subtract my mean. So my mean was 10. So we're going to minus 10, minus 10, minus 10 from all 3 of those values. We are then going to get the values of -2, 0, and +2. And the next thing what we're going to do is square all these values. This is going to give me the values of 4, 0, and 4. I'm then going to find the sum of them. So what we just did right here, in blue basically, is I found the difference of those values. In pink, what I did is I squared all of them to get those positive values. And then in, let's see, in black, what we are going to do is we're going to find the sum of all those, which is 8. So I have the sum of all those values, which is 8. And now what I'm going to do is divide it by my total population, which is 3. So now you're going to find the square root of 8/3. And on these ones, guys, if you want to have an exact answer, you would just rationalize the denominator. But for us, actually, what we are going to do is we're actually going to go ahead and solve this. So when I do all this, I'm going to get a standard deviation, and you can put this more in your calculator of like 2.6 repeating. And you are going to get the value of 1.63, and I should say about 16.3. So what does that mean now? Here's my bell curve. I had an average age of 10. That means 68% of my data would fall between 11.63, what would that be, like 8.57? 57. 68% of my data would fall between one standard deviation of these. And then we would go ahead and add another 1.68 here and subtract another 1.68 here to get two standard deviations. And then once again, to get a third one, you would add those. What I want you guys to realize, it's from the mean. If you have one above and below, this right here would represent 68% of your data. This is 68% of your data. If you were to do it again, two standard deviations away from the mean, this right here would include 95% of the data. And once again, if I were to do this three standard deviations above and below the mean, this would be 99.7% of my data. Okay? So suppose a fourth person that sits down and they're 10 years old. Now I want to show you guys how this really affects the mean and the standard deviation. So what is the mean of the ages? So let's go ahead now and look at my ages. I have a person that's 8, a person that's 10, another person that's 10, and another person that's 12. So now I have a total of 40 years of age. Divide that by 4 to get a mean of 10. So my mean did not change. But now let's go and look at the standard deviation. One more time, guys, that's the whole point of this lesson. I really want us to focus down on what the standard deviation is of a population. And we're basically going to find the sum of the x value minus the mean. And we're going to square that. So you're going to do all this, add them up, and then you're going to divide it by the population. So let's go ahead and start by listing my x values. My x values were 8, 10, 10, and 12. Next, what we're going to do is subtract the mean. Subtract 10, 10, 10, 10. And then what I'm going to do is get a solution there of -2, 0, 0, and 2. And then what I'm going to do is the squaring the part. So let's square, 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 square to get the values of 4, 0, 0, 4. I am now going to add those all up to get 8 again. And then what I'm going to do is, so I have my basically my numerator. So I'm going to plug all that in here now. I'm going to have 8 as my numerator, divided by the population. There's 1, 2, 3, 4 students now. So basically I'm just going to find the square root of 2. And we're going to use decimals here. So this would then give me about 1.41. Now, since I want you to notice, guys, on my bell curve, I have more, my mean stayed the same, it was 10, but I have more data packed towards the mean. I had an additional 10 here. So it kind of brought everything, it kind of squeezed everything closer. So instead of having a spread out standard deviation, I now have it more squished in. So instead of it being, what was it on the previous one? It was 1.63. Now I'm going to have a standard deviation of 1.41. So this would be like 11.41. This right here would be 8.59. So anyways, once again, guys, that means 68% of my data would be here now. And once again, it's squished in because I have more data closer to the mean. So now, let's go ahead and look at the opposite of that. So suppose a fifth person sits down and they're 70 years old. Let's go ahead and discuss this without doing calculations. So what will happen to the mean? So the mean will actually be much greater, okay? The mean will be much greater. Let's think about it. If you go ahead and do this, we would have, what's it called? We'd have the person's ages be 8, 10, 10, 12, and then like super old Mr. Jenkins here. That age right here is going to make the mean much greater. So now if I were to make a bell curve, not only will my mean be way higher, it'll be bigger, but my bell curve will be a lot more stretched out because this bell curve needs to include in it a person who's 70 years old, which means the majority of the data is going to be like over here, like the 8, 10, 10, and 12. In fact, that would be a little bit more closer to the center of the bell curve, but you guys get the idea. So what will happen to the standard deviation? Now the standard deviation, guys, will actually increase big time as well. So one more time, remember I'm looking at a bell curve. Since my mean is way out here now, my mean is much greater, my other values like 8, 10, 10, and 12 are over here, the standard deviation to get most of my data will increase as well. So the standard deviation will be much, much, much bigger now as well. So when I look at this, I actually solved it for you guys. Your standard deviation of the population of these 5 students ended up being 24. So I didn't solve for the mean, but whatever the mean is, I would have to increase it by 24 on each side, and then I would have to take the standard deviation and add it by 48 to get the second standard deviation. I would minus it over here, so on and so forth, okay? Now instead of a 70-year-old, so instead of the 70-year-old person, suppose someone sits down at the table that would increase the mean but decrease the standard deviation. Oops. So I'm going to look at another bell curve, guys. Last thing, how would this take into account? Well, think about this. I have a standard deviation that I want it to be smaller, so I want stuff to get pushed back in here, but I want the mean to increase. So if I looked at here, I had 8, 10, 10, and 12 as my values. And how could I make the standard deviation go down, but the mean increase? So what I would need to do here is, my largest value is 12. I would need to pack it in to make my data basically squeezed in a little bit. Okay, I would need my data to be squeezed in a little bit. So to do that, what I would do is choose a number that is actually greater than 10. So my x value needs to be greater than 10 to have a bigger mean, but it has to be less than 12 to squish my data in closer to the mean. Okay? Hopefully that makes sense. So really quickly, guys, by the end of this lesson, what I hope for you guys to understand is how to calculate the standard deviation, the next part, what I want you to do is understand the bell curve, so finding the mean. And then on the bell curve, the mean obviously always goes right in the center. And then I want you to realize how the standard deviations meet. So really quickly, 50% of the data would be on the right, 50% of the data would be below the mean. One standard deviation above would contain 34% of the data, while another 34% would be below the data. So on this right here, you would have highlighted in here, right there would be included in what I'm looking for. That would be 68% of the data. 2 standard deviations above and below, that would be all of this now. That would include 95% of the data. And finally, a 3rd standard deviation above and below the bell curve, this would include 99.7% of the data. So 99.7% of the data would be here. Let's go ahead now and look at this one. Last 2 things. This one right here, this would be 95% of the data would be included in here. And then 68% of the data, which would be included in here. So if it helps you to look at it like this, that's 2 standard deviations. And last but not least, 3 standard deviations. I know it's super messy and hard to read, but hopefully that helps. Come with questions on that on Thursday if you have it. And yeah, last thing what I want you to do, homework tonight is 9.8.2H. So go ahead and work on that and come with questions as well. All right, guys, miss seeing everybody. Hope you're all doing well. Please feel free to email me if you have any questions. All right, bye-bye.